All right, we're live. Let's try this again. Hello, everyone. I am Verde Robusto. This is the Schumann Resonance Harmonics channel on Facebook and on YouTube. And I want to thank you all for being here. It's Tuesday, what day? The 13th of October, 2020. And hopefully there's not background noise distraction in the microphone. My neighbors upstairs are having a rather lively conversation, apparently. Anyway, so thank you all for being here. I just want to do a quick update on the Schumann Resonances, and I just want to kind of just generally kind of go over what I see here in the spectrograph and in the reporting dependencies, which are these here. Just because I've not actually done one of these, I think here in this kind of fashion, that I'll just go over this briefly. The overview of the Schumann resonance report here from Tomsk. I think it's important to mention other places report theirs in a different way. I've shown this here. This is Italy, the Italian station. This here is how they do theirs. Anyway, so this is the spectrograph, the same thing you just saw in the CIEN. This is a different spectrograph. This one here goes up to 40. Theirs goes up to 120 hertz. Much different kind of thing, and that's the Camerino station that you saw. It's one, even though it's a network, that was one station that you saw. The other very colorful, pretty one. There's not that this one isn't pretty in its own way. I don't mean that, baby. You're fine. Anyway, so this is the spectrograph. This is the thing that everyone calls the Schumann. And then you have underneath it, this is the dependency of amplitude. This is the dependency of quality. This is the dependency of frequency. Okay, so that's what the A is amplitude, Q quality, F frequency. All right, that's helpful. What does that mean? All right, so amplitude is the electric portion of the signal, the electric portion of the program. And so the amplitude generally means height. If you look it up in other places, you'll find height. You'll find, like a wave, an ocean wave. The crest of the wave is the amplitude of, the wave. It's the height of it. And so the amplitude, the electrics, again, people look at that first. The amplitude, they see that maybe because it's the first graph that people see. They focus on a lot of times, not everyone, but, when you see this looked at, observed a lot of time by people's observations, the amplitude, when you go to disclosurenews.it, the parent site here, when they give the power rating, it's of the amplitude. And there's a different set of people, like the Heart Math Institute looks at the magnetics as the power. And that's a whole different discussion altogether. So it's important to remember that the Schumann resonances is two parts. It's not just the one thing that causes the hertz. There's two components to it. One is the electric, and the other is the magnetic, which moves perpendicular. Perpendicular. All right. So that's, where are we? There we go. All right. So that's perpendicular. Parallel, that's parallel. That's perpendicular. Perpendicular. All right. So the amplitude is upright, like such. That's the amplitude. Magnetics is that way. It runs, bounces along the surface of the planet. And the quality, the magnetics, are basically what you're seeing here in these horizontal lines. Okay. So this is a basic description of what you're seeing in the Schumann resonances, the amplitude of these spikes here, bing, bing. The quality is the magnetics here and here. Okay, that's quality. And you have the four modes. This amplitude mode 1, A1, is the tallest of the tall waves. And then you have second in here, and then you have third in there, and then you have fourth. I did a video on the modes to explain what it is, but they're basically like nested eggs, or they're nested components of the same wave, overall wave. They're just broken down into different, so you see the scale here, 3 to 18, then 2.5 to 12.1. They're like filters. It's sort of what these modes are. It's sort of a way to look at it as filters. The modes of the quality are a little different because quality moves that way. All right, remember that. Amplitude, it progresses, this way. Quality goes this way. All right, if you're watching that. All right. So, all right. So this is just a general kind of overall view of what you're looking at here with the graph. Okay. So that's just a basic overview of the graph. These are in pico electron volts. 18 is kind of the highest that it got today, but it'll get to much higher. It'll get much higher. But this is the amplitude. This is the electric part. Even though you see it here, peaking here, this is not a frequency. Okay, so sorry, my power thing dimmed, the screen dimmed because the power needed to be plugged in. So you see they're different, the height of it are different scale. But what we're looking at here, okay, this A2 is the yellow line here, okay? A1 is this white line here. You see that the height of amplitude 1 is at 18. Then you have the height of amplitude 2, that's mode 2, peaks right there, okay? Then you have amplitude 3, it peaks at 9.5. Its peak is right there. And then you have amplitude 4, which is the fattest. That doesn't go tall, it goes fat. That that's peaking out at 6.4. So none of these values here are strong, heavy, hardcore values, but you see there is still the white in this, and the white corresponds to the white here. The yellow and gold and rust and all of that is because it's a combination of these three here. And the green, that mode 4, the pure mode 4, the green, as I call it, is closer, it'll generally be closer to the harmonics. All right, this is amplitude, these are electrics, they're the spikes. There's a spike, nice, clean spike for all of them. Okay, the quality are these right here. So when you look at the amplitude spike, it's upright like that, and you can match it up on the chart right here, but the quality are these horizontal lines here, and it's hard to imagine how you get the fatness, the thickness of those bands from looking at this, but you got to picture that quality on its edge. If you kind of poke all of those lines, how do I say it? You rotate, instead of them going this way, you have to rotate them on their end, so you're looking at them. It's kind of what it is. So instead of like the amplitude is upright, you can see that properly, but these are fat. All right, the video is going to end shortly. This was a very simple update on this.